Welcome to the Learning Pines YouTube. We hope this video helps.
The Smith chart maps normalized impedance and reflection coefficient on one polar plane. Start by normalizing your load impedance to the system impedance. Divide the load impedance by the system impedance to get a unitless value. Plot the normalized impedance as a point using resistance and reactance circles. The center corresponds to normalized impedance of 1 plus J0 and 0 reflection. Use the outer circle for magnitude 1 reflection coefficients and complex conjugate relationships for matching tasks. Plot normalized impedance coordinates using resistance and reactance circle intersections on the chart. Find the intersection that matches your normalized resistance and normalized reactance values precisely. Read the reflection coefficient angle from the circular radial lines pointing from the center. Read the reflection coefficient magnitude on the outer circle as a unitless number between 0 and 1. Convert that magnitude to SWR using the formula SWR equals 1 plus gamma slash 1 gamma. Move toward the generator by adding electrical length measured in wavelengths around the chart circumference. Rotate the plotted point by the corresponding electrical length to find the transformed impedance. Choose a stub type and position to cancel the residual reactance at the target location. Use a single stub to cancel reactance and achieve a matched impedance of 1 plus J0 if possible. Calculate required series or shunt element values from normalized susceptance or reactance. Read directly from the chart. Convert normalized values back to actual ohms or lengths.
Thanks for watching. Consider subscribing if we helped you.